Hello, my name is Colin McEwen and welcome to the BBRO. Today we've got an opportunity just to talk briefly about what BBRO does. BBRO plays a very important role in linking the science behind sugar beet research to the practical approaches that farmers take. One of our roles is being impartial and independent, and it's important all the work that we do is linked to actually applied research. We've based ourselves at the Norwich Research Park, where we've got access to the John Innes Centre, UEA and some of the other research organisations nearby, which gives us an excellent base.
We've got a range of projects covering everything from variety trialling through to fungicide evaluation, herbicide evaluation, some long-term storage trials, some work on nutrition and spatial arrangement. 18 different programmes running over about 21 sites, spread from Humberside down into Suffolk. We tend to concentrate on work which is, whilst it's scientifically interesting, it's actually commercially worthwhile. We've always got an eye on how we're going to get that out into the marketplace as well.
Hello, my name's Mark Stevens, the lead scientist for British Beet Research Organisation, and for the last 25 years I've been actively researching into one of the most fascinating crops I think that's grown in the UK. There are still many challenges that we need to be able to tackle. For example, root rots continue to cause some growers problems, particularly in Norfolk, and we have a new research project looking specifically into violet root rot and trying to identify new strategies to control it. Climate change is also a risk, and we are aware of other pests and diseases in other parts of the world that could potentially in the future cause us problems. But one area that we do know much about and have invested much money is rhizomania of sugar beet. Now, rhizomania was first identified in Suffolk in 1987, and we've actually had to deal with it for 25 years now. Much effort, money, resource, and many growers have been affected by this disease. But what we do know is that the current varieties provide excellent yield potential in the presence of this disease. However, diseases always try and be one step ahead of the game, and that was certainly very evident in 2008 when we identified a new strain of rhizomania, the AYPR strain. This potentially can decrease yield in affected areas by up to 80%, and occasionally I've observed its ability to kill the plant.
One of the roles that I'm very passionate about is engaging with growers, ensuring that they get the best independent impartial research that we can provide, and ensuring that that research is applicable to what they do, that actually they can use on farm.
I'm Demi Sparks. I'm an Associate Professor in Agronomy at the University of Nottingham, and I've been involved with the BBRO over the last year or so, initially doing a research review looking at future research priorities in crop production. The research review had three areas to work on. One was to address current growers' concerns in areas such as crop nutrition, plant population. One was to look at underpinning research so that we could progress crop productivity in the future. And one of the key areas that came up there was water uptake, because it's known that on average the yield of sugar beet is reduced by 10% every year due to lack of water, and in dry years it could be 25%. And the third area was to maximise return on the BBR's investment. So for looking at research that they've done in the past, don't let that go, make sure that they can continue with that.
Over the years, we've provided biological, serological and molecular diagnostics, which are key for when you're trying to understand problems like this. This is the new strain of rhizomania, and by using those diagnostics, not only are we able to confirm the presence for the grower, because potentially that could also be caused by other soil-related issues such as nematodes, but it also allows us with the latest technology to understand exactly what strain it is by looking at the genetic makeup of that virus isolate, fine-tuning the advice that we can then pass back to the industry, selecting appropriate varieties for future use.
The X-ray CT is a technique that's been used widely to really look inside the structure of all different sorts of organisms. And we'd either take cores from the field and look at the soil structure on those cores, or we'd actually grow plants in a small vessel like a cup and track root development over time. And the scanner will allow us to do that because it's non-destructive and we can keep going back and following root development in soil. The new building that's being put up is going to bring together that small scanner together with two much larger scanners, and the larger scanner will take columns about 30 centimetres in diameter up to a metre in depth. and that will allow us to grow plants over an extended period of time and scan their rooting development and correlate that with the crop growth above ground. We can also measure water uptake from different layers of the soil profile while that crop growth is going on. So it will enable us to really follow root growth, water, nutrient uptake in detail over an extended period of time, and to gain some insights that we really can't get just from field work or normal glasshouse work in pots. And the yield of the crop is all about light interception. So if you've got patches of the field where establishment is poor and there's big gaps between plants, the light that should be hitting leaves and driving sugar yield is hitting the ground as it is being wasted. So if there are areas of the field that establish poorly, that's a real loss of yield. And one area that we'd like to look at is predicting establishment based on soil properties at drilling. So we've done some similar work in wheat, where we've looked at soil physical properties like soil aggregate size, bulk density, shear strength, which are properties that can be quickly measured in the soil, and we've been able to predict establishment with good accuracy. So what we'd like to do is to see if we could do the same in sugar beet and eventually lead that through to some sort of app or sensor that could be positioned on the front of a tractor and could look at the structure of the soil and use that to vary the seed rate on the go. And I know a lot of growers have already got drilling equipment that will allow them to vary seed rate. So if that could be linked to a sensor that's based on, let's say, the aggregate size of the soil, where you've got small aggregates and that predicts high establishment, the seed rate would be lower, and where you've got a large aggregate size of a cloddy seed bed and you're likely to get lower establishment, the seed rate could be increased to try to get a uniform plant population across the field and maximise yield in that way.
We're interested in driving up sugar beet yields as fast and as hard as ever we can, and you might think that those yields will plateau off after a period of time. In truth, we're still on the upward curve, and you could almost argue that curve is accelerating. The question is often asked about GM. Do we need GM to enable us to get to the next level? I'm not sure that that's necessarily the case. I think GM technology may bring about a change in the pace of development, but if you look at how the sugar beet crop has developed through conventional breeding, it's come an awful long way, and there's still masses of potential to get out of that conventional breeding route. The use of genetic markers is enabling much faster and much more accurate selections from breeders' lines, which is speeding up the rate at which material is coming forward. We are currently evaluating 140 different candidate varieties for future years. There's plenty of new material coming through the pipeline. We are always vigilant, always looking out there as to where's the next big challenge, the next big threat to sugar beet, keeping our eye on diseases which might be prevalent on the continent and may come over here, climate change, all these sorts of variables.
This is an example of Cercospora leaf spot in places in Germany and Italy and France can decrease yield by up to 40%. Fortunately, it's a disease that likes it very warm and quite wet, and so far the conditions we have in the UK are not that favourable, but once again we provide a surveillance monitoring system, keeping an eye on the UK sugar beet crop just in case this disease becomes more of a problem in the future.
The sugar beet crop for me is one of the most exciting crops to work in, mainly because of the direct link we have with the processor, that combination of access to what happens in the factories from what's happening on the farms allows us to bring new technologies forward to the market very quickly. The challenge we face is the success of sugar beet's yield improvement over the last 10 years. We need to try and continue. We need to look for ways to help growers achieve and maximise their yield and profitability, and that will be our target over the next 5 to 10 years.